Hello class, this is Michael representing for Group 5. So William and I worked on website and email phishing detection using machine learning techniques or algorithms. So our presentation is short. I will walk you through 4 overviews. First, I'll talk on the introduction and then the methodology. I'll move on to the data set, and finally I'll talk about discussion, which includes the results and analysis. As we all know, website phishing can be described as mimicking a trusted website to obtain sensitive information from online users. This information can be username, password, or financial information. Usually this starts with an email sent to the victim. The attacker will send the victim an email, and this email usually contains the URL link to the phishing website. These attackers always try to come up with new ways to fraud people. So this has been a problem for quite some time now, and it's still a problem. So here, this is the method we used. This is a supervised learning task, and we all know there are 2 major types of supervised learning tasks or problems, be it classification or regression. We will use and this problem falls under the classification category, because we want to classify a link or a website as being a phishing website or a legitimate website. So this is a classification problem. So here what we did was to look at the content of the URL itself, the content of the link itself. So the link that the victim will receive through an email is what we looked at, because most of the times the links that takes us to a phishing website, they come with certain indicators that let us know that this link will take us to a phishing website. Normally they contain IP address. As we all know, an URL or a website shouldn't contain an IP address. So each time we see this, it rings a bell. And also sometimes the links are too short. The number of characters that make up the URL link are too short. And this works in 2 different ways. It shouldn't be too short, and also it shouldn't be too long. From our research, we find out that links that usually contain more than 54 characters are normally phishing links. So ideally, the number of characters should be less than 54 in a link, and also it shouldn't be too small, say 3 or 4 or 5 or 6 characters making up a link. It should be more than that, and also be less than 54 characters. Then the next thing you find out is that a web page can have multiple redirected pages, or multiple links on that web page will redirect you to a different web page. If that happens, that should also ring a bell. And finally, when we look at the website traffic, usually legitimate websites have high traffic because they are being visited regularly. On the other hand, phishing websites or links, they are not being visited regularly. They are only used for a short period of time, just so the attacker can achieve his or her aim, and then he or she will shut down the website. So when you look at the traffic that is being generated on that website, that should also help you identify a phishing website from a legitimate website. So as I said, this problem is a classification problem. we used 3 supervised learning algorithms to help us with the classification. The first one is the random forest algorithm. Second, we use the support vector machine or support vector classifier. Lastly, we use the logistic regression algorithm. So we had a data set from Kaggle, which we all know is an online community of data scientists and machine learning practitioners. This data set contains 10,000 instances with 18 attributes. From the 10,000 instances in the data set, we found out that 5,000 instances were phishing instances, which means they contain phishing URLs. And then the second 5,000, they contain some legitimate URLs. But the problem in the data set was that due to how data was extracted, the first 500 rows or instances in the data set were the phishing instances. And then the second 500 rows were the legitimate instances. So before we split our data set into training and test size, we had to shuffle the data set. We had to make sure that the number of phishing URLs are not just in the top 5,000 rows, and also the legitimate ones being in the top or in the bottom 5,000 rows. We had to shuffle the whole data set and mix them up. That way we will have an even distribution before we split the data set into training and then test size. So we did that, and then we used 16 features out of the 18 features that we had. We had to drop 2 features that were not necessary for our model. We dropped the label feature and also the domain feature, which contains the URLs, and then the label feature contains a number of either 1 or 0. 0 being the legitimate websites, and then 1 being the phishing website. After that, we went ahead to look at the correlation metrics. The correlation matrix shows us the pairwise correlation between all the features or attributes within our data set, and this only shows the features that contain numeric values. That way, the algorithm can look at the correlation between these values. So if you look at this carefully, you'll find out that we don't have the domain feature here. The domain feature is not captured in the correlational matrix because it contains alphabet. It contains alphabet, not numeric data. And then also we looked at the confusion matrix. This matrix helps us visualize how many samples from each label was predicted correctly. It allows us to see where the model failed and then where it succeeded. So from here you will see the results. The first results here has to do with the logistic regression results. After we ran the program, the logistic regression F1 score was 0.7984, and then it had a testing accuracy of 80.2. So that's a testing accuracy for our logistic regression algorithm. The second algorithm we used was a support vector classifier that produced an F1 score of 0.81096. and also had a testing accuracy of 81.55. And then finally, we looked at the random forest algorithm that came up with an F1 score of 0.8639. And then the testing accuracy for this is 86.45. So among these three algorithms that we used, when we compare the results, we'll find out that random forest produced the highest results. And this is no surprise because the algorithm first selects random observations. The random forest algorithm first selects random observations. After that, it builds multiple decision trees based on this randomly selected observations. And then finally, it merges these multiple decision trees together to arrive at a more accurate and stable prediction. So this is why the random forest algorithm in our situation performed better than the support vector algorithm and also the logistic regression algorithm. Thanks for watching. This is Group 5's presentation for this course, Machine Learning. Thank you.